Is AI coming for the classroom? And if so, what does the evidence actually tell us about what happens next?
That is the central tension we keep seeing in the headlines, right? You read these sensational warnings.
hmm
We saw a recent survey finding that nearly a third of experts predict that AI could put teaching jobs at risk within, what, the next 2 decades?
Yeah, and it's an attention-grabbing, fear-inducing number.
Totally.
It is. But as we so often find with any powerful new technology, that headline, it kind of misses the deeper, more nuanced truth that's in the data.
Okay.
So our deep dive mission today is to move past that sensationalism and really look at the empirical findings from our sources.
Yeah.
And the core insight we uncovered, it's pretty clear.
Which
AI won't replace great teachers.
But there's a but.
There's a but. Teachers who use AI are going to fundamentally change teaching.
Okay, let's unpack this. We've got a fantastic stack of sources here from, these big systematic reviews of the risks to highly specialized papers on personalized tutors and feedback agents, all powered by generative AI.
Right.
So our goal is to explore the specific, empirically studied impact of large language models, or LLMs, on both the, let's say, operational effectiveness of educators and the cognitive development of students.
Exactly. And to make this manageable and structured for you, we're breaking the analysis down into 3 main sections.
Okay.
First, we'll look at how AI is saving teachers time, reducing that administrative load. Second, we dive into the grand challenge of how AI enables personalized learning at scale, the famous 2 sigma problem.
And then the risks.
And then finally, we will explore the critical, technical, pedagogical, and societal risks that really must be actively managed as this whole thing accelerates.
Let's start where the benefit is most immediate and tangible. AI acting as the ultimate operational lifesaver for educators. This is the simple, powerful classroom assistant role.
What's immediately fascinating here is when you quantify the sheer scale of the administrative relief that's needed.
Right.
The research shows that teachers spend, on average, almost 10 hours each week just on routine, non-instructional tasks. So things like draft lesson planning, customizing materials, grading.
10 hours. I mean, that is an entire additional day of work every week.
It is.
Just on the routine stuff that takes them away from actual teaching or, frankly, having a life. So what are the concrete AI solutions that are providing these real measurable efficiency gains?
The current solutions are getting quite comprehensive. LLMs can now generate draft lesson plans that are already aligned with specific state or national educational standards.
So that just cuts down the initial legwork.
Drastically.
Yeah.
They can instantly suggest differentiated activities for students at various skill levels, which was a huge time sink previously. They organize digital resources. They summarize assessment data into insights that are, actually actionable.
And communication.
And instantly generate templates for family outreach and communication.
Yeah, that's significant. One source we looked at noted that freeing up even just a half hour a day, or say 4 hours a week, could genuinely make the difference between a teacher suffering from burnout and one who can sustain their passion.
And the research suggests they reallocate that time to the highest leverage activities that AI just can't touch.
Like what?
We're talking about one-on-one personalized mentorship, deep student relationship building, nuanced parent communication, or, investing in their own professional development.
So the crucial context here is that the integration of AI, when it's guided by smart policy, could actually help retain great teachers by making their workload sustainable. So far from eliminating the profession, it sort of stabilizes it.
Precisely. It could help stem the high turnover rates we currently see.
Mm-hmm.
But there's a big caveat that all our sources underscore, and this is key to the whole narrative.
The outputs still require human oversight.
100%.
Absolutely. The machine can generate a suggested grade or a lesson idea, but it needs the teacher's professional knowledge, their understanding of that specific classroom's social-emotional dynamics, for review, for customization, for accuracy checking.
The thinking, the reflection, the meaning-making, the ethical consideration. These things still belong to the teacher and the learner.
Yeah.
We saw one analogy that summed it up perfectly. A hammer can build or destroy.
Right. The tool itself is neutral, the purpose and the skill of the user determine the outcome. So the takeaway from Section 1 is, efficiency is great, but only if it's targeted with precision, like that hammer.
Yep.
Now, let's pivot to Section 2. The research stack shows us that AI is aiming much higher than just managing email and lesson plans. Let's look at the grand challenge of individualized instruction, this immense potential of AI to solve the challenge of personalized learning at scale. And this brings us to the famous 2 sigma problem.
This is where it gets really interesting and, frankly, why researchers get so excited. Decades ago, the educational psychologist Benjamin Bloom established a benchmark, the 2 sigma problem.
Right.
He found that students who received sustained one-on-one human tutoring outperformed control students in traditional classrooms by 2 full standard deviations.
That's a massive, almost unbelievable performance gain.
It is. It was proof that individualized instruction works miracles, but it was historically impossible to replicate at scale.
Because you just can't hire a personal, highly qualified tutor for every single student for every subject.
Exactly.
And generative AI is changing that calculus. It's providing the infrastructure for that individualized content.
That's the core thesis. And we're seeing compelling case studies of personalized learning applications like GPTutor, which uses powerful LLMs like GPT-4 to customize course content.
And not just based on difficulty, right?
Not just on difficulty, but on a student's specific interests, their hobbies, or even their career goals to really enhance engagement.
And this is where the examples start to sound genuinely transformative. You're not getting generic, abstract math problems anymore.
No.
You might be learning complex linear regression concepts using the analogy of Gojo's screen time and popularity in the anime Jujutsu Kaisen.
Exactly. And that tailored relevance is what drives engagement and, crucially, makes the content sticky.
If the student cares about the analogy, they care more about the math.
That's the idea.
But another crucial part of individualized learning is feedback. Feedback is how learning is cemented, but teachers just rarely have time to provide truly deep, actionable feedback for every student on every single assignment.
That's where the cutting edge of the research is focused.
Yeah.
Researchers are effectively using AI to teach AI how to be a better grader.
How does that work?
They developed a framework called Synthetic Educational Feedback Loops, or CEFL-2. This involves setting up 2 distinct LLM agents. One is designated as the teacher, the other is the student, to simulate the full assignment feedback loop.
So these agents essentially talk to each other, and they role-play the learning process to generate just massive amounts of realistic training data for a third model.
That's exactly right. The source notes they generated 19.8 thousand synthetic assignment feedback pairs.
Wow.
And this massive high-quality data set is then used to fine-tune smaller, more computationally efficient LLMs that can be deployed widely.
What stands out to you about the findings, specifically regarding the style and the quality of that AI-generated feedback?
The quality leap was clear. Human experts judged the CEFL-tuned models as generally outperforming the non-tuned versions, particularly on 4 key criteria for effective feedback.
Which were?
Accuracy, actionability. So giving the student a concrete next step. Conciseness, because students tend to favor brief comments they can process quickly, and maintaining a constructive tone.
So it actually sounds encouraging.
The models learn to sound helpful and encouraging, not just evaluative.
So we have efficiency gains in operations, and we have measurable qualitative gains in personalized content and actionable feedback. It seems like a clear win.
It does.
But this brings us to the necessary pivot, the trade-offs.
It does. It's powerful, but it's not a slam dunk. And this brings us to the most critical section of our deep dive, the inherent technical, pedagogical, and societal risks that have to be actively monitored and managed.
Okay, let's look at the pedagogical risks first. I think we all intuitively understand that if you outsource intellectual labor, you might reduce the effort, but the sources provide neuroscientific evidence of what exactly is being reduced.
This is the cognitive paradox. LLMs are excellent at reducing what's called extraneous cognitive load, that frustrating struggle associated with, say, poor formatting, unclear instructions, or hunting for resources.
And getting rid of that is good.
Removing that distraction is good, but they risk diminishing germane cognitive load, which is the actual heavy, productive mental effort that builds robust understanding and long-term memory.
We need an analogy here. If extraneous load is the frustrating struggle of reading a badly formatted textbook with tiny print,
Right.
then germane load is the mental muscle your brain needs to build the complex structure of knowledge.
Perfect analogy. And the consequence of bypassing that germane load is startling. Studies using high-density EEG found that students using LLMs for essay writing showed diminished neural activation.
In which parts of the brain?
In brain areas associated with semantic integration, creative ideation, and executive self-monitoring. In simpler terms, if you use AI to do your assignment, Your brain simply isn't working hard enough to actually internalize what you just wrote.
And we see that cognitive debt manifests directly in memory erosion.
Yes. A study found that students relying on LLMs had significantly more difficulty recalling specific quotes or arguments from their own AI-assisted essays compared to those who did the work independently.
Which points directly to shallow memory encoding.
Exactly. The content was generated and processed, but it was never truly internalized into deeper memory.
And this feeds directly into what researchers call metacognitive laziness.
That's the psychological risk.
Yeah.
Because LLMs generate text that is highly fluent and often authoritative in tone, they sound confident and correct. Students engage in what is called verification drift.
They just stop checking.
They reduce their critical evaluation, passively accepting the answers instead of questioning them, which is, the cornerstone of critical thinking.
And compounding all this is the academic integrity challenge. If students are using AI to generate content, the line between their work and the machine's work is it's blurred.
It's a major problem for assessment reliability. Research shows that pre-service teachers, so those just about to enter the field, struggle significantly to distinguish between student-authored and AI-generated texts.
They can't tell the difference.
Often no. LLM outputs are now often linguistically and stylistically indistinguishable from human-authored academic writing.
Let's pivot to the technical risks, starting with the most infamous one, hallucinations.
Hallucinations are defined simply as the LLM generating outputs that deviate from established facts, or worse, fabricating citations and events entirely. And this moved from a technical curiosity to a real-world catastrophe very, very quickly.
And the real-world consequence is already visible.
It is. The sources cite the terrifying example of a lawyer who inadvertently submitted entirely fabricated case citations in court after relying on an LLM for his research.
Wow.
That is a massive, immediate failure of critical verification, demonstrating the severe consequences of blindly trusting the tool.
And beyond outright fabrication, there is the structural, technical risk of bias amplification, which stems from the training data itself.
Correct. LLMs encode, and then they amplify implicit biases present in the massive data sets they are trained on. And we see this in several ways. For example, research found that LLMs showed subtle but measurable bias in grading identical essays when those essays were paired with demographic cues.
Like race or socioeconomic status.
Exactly.
So the bias isn't just in the generated content, it's in the entire evaluation loop.
That's right. And furthermore, generative AI often produces stereotypical representations in its outputs. If you ask for images of a chemist or a medical student, the resulting images are predominantly portrayed as male or representing a specific demographic.
And that just reinforces those societal stereotypes.
Mm-hmm.
Finally, we need to spend sufficient time on the societal risks, touching on equity and the environment. Let's start with the AI divide.
We see three immediate levels of inequality emerging in education: access, use, and outcomes. LLM development costs are astronomically high. This naturally concentrates power, resources, and innovation in wealthy nations and institutions.
And what does that mean for the global south?
It risks excluding learners and institutions in low and middle-income countries from utilizing the very tools that could potentially solve their educational scaling problems, and so it deepens global educational inequalities.
And this disparity is reinforced by what researchers call data colonialism, which is a powerful and concerning term.
It is. It describes how powerful nations and tech companies disproportionately control the data flows and the labor required to build these systems.
And there's a concrete example in the sources.
A profound one. Kenyan workers were hired to label harmful content for OpenAI models, a crucial ethical task. They were paid minimal wages, exposed to traumatic material, and bore significant ethical burdens without ever reaping the technological benefits of the sophisticated systems they helped refine.
That puts a human cost on the AI revolution that is so often invisible to the end user.
Absolutely.
Mm-hmm.
And lastly, the environmental footprint is a serious long-term concern. Training a single large model like GPT-3 consumed approximately 1,287 megawatt-hours of electricity.
Which is an enormous amount of energy.
It is, emitting over 550 tons of CO2. As these models scale and become ubiquitous, the high resource requirements present a significant environmental challenge to sustainability.
So if we accept that the risks are real, how do we move forward responsibly? We have to shift the focus from pure, unmanaged efficiency to integrating AI with wisdom and strategy.
The discussion shifts squarely to mitigation strategies, and the new essential skill for both educators and students is prompt literacy.
That makes perfect sense. Effective integration relies on knowing how to interact with the AI to get the best, most focused result, rather than just typing a lazy command.
Exactly. The Malik and Malik model provides a wonderful framework for prompt engineering that is pedagogically sound. It involves explicitly defining the LLM's role.
Like you are a critical writing coach.
Exactly. Then defining the goals, setting hard constraints, and specifying the pedagogical strategies it should use. This transforms a general, lazy output into a specialized, helpful tutor.
This strategic use also supports the fascinating research suggesting AI may actually invert Bloom's taxonomy.
For anyone who remembers those learning pyramids from school, AI might just flip the whole thing on its head. Traditionally, learning progresses linearly from foundational skills, remembering, understanding, up to higher order skills like evaluating and creating.
But the AI changes the starting point.
It does. AI allows students to engage in higher order tasks, like creating an essay draft or evaluating an AI-generated solution right from the outset.
And the AI then scaffolds the foundational knowledge acquisition, the remembering and understanding as needed to support that creative task.
Right. So instead of spending weeks learning all the isolated rules of chemistry, you might start by creating a complex solution to a problem. And the AI tutors you on the specific rules you need as you encounter roadblocks.
That puts the student immediately into active engagement.
Precisely, which requires clear mitigation strategies across the board.
So for educators, the strategy is about updating what we teach.
Yes. Revise learning objectives toward those higher order skills, critical analysis, knowledge transfer, strategic problem solving. Provide specific LLM literacy training to guide students to use directive prompts, not to outsource entire tasks, and maintain that essential human monitoring for integrity and critical thinking.
And for the developers creating these tools, the ones who hold immense power in shaping the classroom of the future,
They must prioritize learner-centered design, not just technical prowess. This means incorporating explainability and transparency cues, so students understand how predictions or suggestions were made, and critically, they must continuously diagnose and mitigate bias in the training data itself.
to avoid reinforcing those stereotypes we talked about.
Exactly.
And finally, for the students, the ultimate users of this technology, what is their responsibility?
It's a three-part responsibility that really requires a shift in mindset. Verification, you must cross-check LLM outputs with reliable sources. Responsible editing. Treat AI as a support tool, never a substitute for effort. And most importantly, active reflection on the cognitive and ethical implications of their usage patterns.
Okay.
To synthesize everything we've discussed, AI offers unprecedented speed and efficiency in administrative tasks, and the genuine promise of truly personalized instruction that can address historical inequalities like the Two Sigma problem.
But speed and efficiency are not the same as wisdom.
Never. Only humans can provide the authentic connection, the belonging, the care, and the necessary professional judgment to guide intellectual development.
That brings us back to the management theorist Peter Drucker's enduring insight, which seems more relevant now than ever. There is nothing so useless as doing efficiently that which should not be done at all. AI offers efficiency, but humans provide the purpose and the wisdom to determine what truly deserves our effort and attention.
Absolutely. And this leaves you with our final thought for the listener today. The challenge moving forward lies in the neurological reality of LLM use. Instant AI answers provide an immediate, quick reward, a dose of dopamine and instant gratification. But they compromise the robust memory encoding we need for deep learning. How will you balance those quick rewards against the enduring satisfaction and robust skill development that comes only from effortful, independent problem-solving and critical thinking? Which path will you consciously choose in your own learning?
Something profound to think about as you navigate the new digital landscape. Thank you for joining us for the deep dive.